Appreciate it. Welcome, everybody. Like Luke said, my name is Damir Bersinic. I am the Cloud Infrastructure Solution Specialist on our Global Black Belt team for computing in enterprise, cloud enterprise, part of Microsoft. Really, what I spend most of my time doing is talking to customers about how they can transform their business through Azure in particular. And very often that conversation starts off rather simply with the customer kind of asking simple questions. What's cloud computing? What's Azure? In a lot of cases, they may have heard of it. They're, comparing it to other things that they're familiar with, but the reality is they may not necessarily always be fully aware in terms of what the capabilities of our platform are and what the different elements of cloud computing happen to be. So, kind of starting there and then building on in terms of how you can leverage Azure, what are some of the capabilities of Azure, as well as how to actually get there. Very often, and one of the questions once customers are looking at cloud computing is, where do I start and what are some of the tools available? We can cover some of that as well, and I'm more than happy to answer any questions you guys have along the way as well. So let's start off with what's cloud computing. You probably heard three different acronyms, IaaS, PaaS, and SaaS, and really those are three different types of cloud computing elements. And on the Microsoft side, we actually support all three, and I'll get into in terms of what's in each one of those as we go further. But it's important to differentiate at this level that cloud computing is very different from hosting. Right, so companies like Rackspace, for example, provide hosting services, and that's very different from cloud computing, where according to the NIST definition, cloud computing is an on-demand, self-service capable service with broad network access, supports resource pooling, which gives you the illusion of infinite scalability and infinite resources, rapid elasticity, being able to scale up and down as required, and it's also a measured service where every single element is basically, as you use it, it ends up being something that you can actually go ahead and measure. And from our perspective, we could potentially end up, assigning a cost to it as well. So the key thing with regards to cloud computing is you pay for what you use when you use it, as opposed to making any kind of upfront statement. Well, I'm going to commit to running these servers for a year. It's going to cost you X dollars every single month, whether or not they're turned on. So that's the first thing with regards to cloud computing. The second is then you get into, okay, well, what does all those things actually mean? What's between running stuff on premises versus running it in the cloud? So on premises, when you think about the way you're running your infrastructure today, you're responsible for everything, right? So you bring in the network gear, you bring in the storage, you bring in the compute, you hook it all up together, you install the operating systems, you install your virtualization platform, middleware for the applications, the runtimes, the data that's going to be used by the application itself. And you're responsible for maintaining everything, you're responsible for patching everything, for keeping it up to date and so on. And you make the upfront investment, and whether or not you actually use everything you purchased is really dependent upon whether or not, you've exceeded capacity or whether you have extra capacity. Once you move to the cloud, it really ends up being, something very different in that what you end up paying for is what you actually end up using. And there's three different variants, like I mentioned before. We go to the far right. When you look at software as a service, and a good example of that is Microsoft Office 365, where we have Exchange Online, SharePoint Online, and so on. We basically run and maintain everything. The only thing you guys are responsible for is assigning users and giving them mailboxes or giving them access to SharePoint sites, and we manage the entire infrastructure for you. That is obviously a great solution in situations where, you don't necessarily want to run email servers. And my personal belief is nobody should run email servers anymore. It really is more or less a commodity thing these days. It's not anybody's competitive advantage to have email because everybody's got email. But software as a service is a very, very viable solution, for things like email, SharePoint, and so on down the line. ERP systems are going that way as well. So Microsoft Dynamics CRM, Microsoft Dynamics AX, those are all software as a service-based platforms. Infrastructure as a service is probably the simplest way to get onto cloud computing, in that you are running virtual machines on-premise, and you simply take that VM from on-premise and move it into Azure. And you no longer need the hardware to run those VMs because we supply that for you, but what we manage at that particular point in time is networking, storage, the servers, and a virtualization layer, but everything within that VM is still your responsibility. So the OS in the VM and whatever is running in that particular VM is still your responsibility. So you simply moved it from on-premise to the cloud. And that actually makes good sense in a lot of cases. For example, dev test environments or QA, where you don't actually have to have those VMs running all the time, only when you're actually doing dev tests or the QA piece, and you're not actually taking up expensive resources that you would on premise for that particular workload. Where the cloud really tends to have a huge amount of value for organizations when they start to move to platform as a service, where we manage everything else for you, but all you think you really are responsible for is applications, so your application code and the data that's used to manage that particular application. And we manage everything else. And also platform as a service, as you're going to see in some of the capabilities we have in Azure, gives you much easier scalability. So let's say you're a retailer and you want to make sure that during your peak periods around Christmas, around the holidays, you've actually got a lot more website instances available to process, customers going in and browsing and ordering items at that particular point in time. So you can very simply say, well, I want to scale to 1,000 instances, and during that period you do, or you can scale based upon demand. And once demand goes away, you scale back down, and that can be an automated process. That's very easy to do in a platform as a service environment. It's a lot more difficult to do that with virtual machines. So the real value of cloud comes when you start to be able to leverage some of those platform as a service capabilities. But the reality is most customers will start with infrastructure, or some of them will also take some of the infrastructure workloads and take some of the other workloads like email and SharePoint and move those to platform as a service, and then start to adopt, software as a service, and start to adopt platform over time. Now, I always like to compare things to pizza. If you compare cloud services to pizza, right? On-premises is basically you doing everything yourself. You're getting the cheese, you're getting the toppings, you're getting the tomato sauce, you're getting the pizza dough. You're making sure that your oven's on, you're putting the fire in place, using electric or gas, it doesn't really matter. Getting your soda, you're getting your dining table together, you're serving everything, you're washing the dishes, you're cleaning up after the fact, and you're doing all the work. You can do it that way. It just typically ends up being a little more expensive. My favorite is the Italian restaurant, the software as a service element, where you go in, you order, you sit down, and they do all the work for you. You don't necessarily care, what the pizza dough is made of unless you ask for a gluten-free pizza, which you can. You don't really care what's in the tomato sauce or what kind of cheese they're using or the things of that nature. They can more or less have taken care of that for you. What you're really worried about is just enjoying a great meal and having good conversation. Platform as a service is like, your pizza or Panaggio or whatever the local pizza place happens to be out west. You simply, call up, have them deliver the pizza to you, and all you do is you eat and you have a drink, and there you go. Whereas infrastructure is like you walking into a grocery store or a Costco or a Loblaws or a Sobeys, and you pick up the ready-made pizza and then you cook it at home. So if you kind of look at cloud computing in those scenarios, infrastructure is bring home your own pizza from a grocery store. Platform is do takeout, and software is go to a nice fine restaurant. So how does that relate to Azure, and what is Azure? So if you look at Azure, and this is what I call the big picture slide, and this lists out some of the Azure services. So the first thing around Azure, it is a collection of services. It is not a platform. It is a collection of services that sits on top of data center infrastructure that we run on a worldwide basis. The three key elements of Azure are at the bottom: compute, storage, and networking. So very similar to what you actually have on your on-premise infrastructure, where you're going to have networking gear to connect your stuff together, storage to store your data, and compute to actually run your workloads. We have the exact same kind of thing in Azure. When we're talking about infrastructure as a service of running VMs, that's where you're using compute, using blob storage to actually store your data, and networking to virtual networks and other networking elements to connect those pieces together. So very, very similar to what you have. So that's why taking a VM into Azure is actually very easy. You architect the network, you define a storage account, determine VM sizes, and basically move that up into the cloud. There's other services around that are actually very, very important. So if you look on the left-hand side in security and management, there's things like Azure Active Directory, which allows you to integrate your on-premises AD with Azure and then be able to assign permissions to resources you have in Azure using the exact same groups and users that you have available on-premise, so that you're not actually having kind of two separate types of mechanisms for assigning permissions and determining identities. Other things in there is there's a VM image gallery and VM depot, so the capability to actually have your own images or be able to basically instantiate images in Azure that are predetermined or provided by marketplace vendors. So you can have a SUSE Linux image, a Windows Server image, a Red Hat image, an Oracle database image. Those are already ready to go, and you simply churn those on and then run them within your Azure environment as well as a number of other services, basically to kind of ensure things are working properly. In the middle, we have what we call our platform as a service services, and we have a large number of those. And this is, like I said before, we have the real value of Azure and cloud computing comes to bear. So, the SQL database services, data services around SQL database, SQL data warehouse, some NoSQL as well as MySQL type services, Redis cache, SQL Server Stretch database to link your on-premise to the cloud database as well as BI and analytics services and things like Bot Framework and Analytics, and as well as Hadoop, which is HD Insight. So Hadoop clusters, machine learning, and so on down the line. A lot of really, really great things. But also, from the standpoint of running things like web applications, really you can run a website in Azure and VM with either Apache or IIS. But the reality is you probably want to run websites in Azure as a web app. And the tools to develop those applications, whether you're using Visual Studio or Eclipse and so on, can be the exact same tools you end up using to deploy those applications. So a lot of platform services. I'm going to spend some time also talking today about hybrid cloud, and there's two things there that are really important, which I get into a little more. One is Azure Cyber Recovery, which is the second from the bottom, which is a way to migrate your application, but also provide DR for your on-premise workloads within Azure, as well as things like Azure Backup and StorSimple, which is a hybrid capability to basically introduce hybrid cloud capabilities where the storage that you have on-premise can now be extended into Azure and start to leverage cheaper Azure storage for some of the data that you have on-premise as well in a secure, encrypted, and compressed deduped environment. So a lot of different services. Really, I could spend an entire week on this. Ask Luke, because he's actually seen me kind of go through this stuff in a lot of detail, but there's a lot of things you can do there. The other thing to keep in mind is, our footprint with regards to cloud computing is actually very broad. So we have 38 regions worldwide, 32 that are actually generally available. Actually, I think the number is now 35. We've gone up since the last time I put the slide together. And a region is essentially one or more data centers. So we have 100 plus data centers around the world. We have 2 data centers in Canada, one called Canada Central that's in Toronto, another one called Canada East in Quebec City. Those data centers also ensure that the data that you store in the data centers is going to stay in Canada. So we do meet Canadian residency requirements, and if you geo-replicate your storage between the two, the actual traffic between those 2 data centers is also going to stay entirely within the country. So one of the questions I often get asked by public sector organizations, financial services, healthcare, and so on is, can you ensure data residency? Can you also ensure that my data is going to never leave the country if it's replicated between data centers? And our answer is yes. In fact, our network footprint within Canada between those data centers will also stay entirely in Canada as well. So we do ensure Canadian residency. And again, if you're a worldwide organization, you can, in fact, deploy your workloads anywhere around the world. There's a couple of special cases here. One is China. In China, the data centers are for Chinese entities only, and they're not really connected to the rest of Azure. They are kind of separate because of Chinese requirements, although they can be made connected. It's one of the things that we can definitely discuss with you if you have operations in China as well. But we tend to have a very, very large footprint. We have the second largest network in the world today, larger than anybody else. Right, so if you can think of any other cloud provider, our network is actually larger than theirs right now. One of the things that we're actually providing customers is the capability to leverage our network backbone as potentially their backbone to communicate between different subsidiaries around the world. There's a couple of projects I'm working on around that right now. And we also have some very, very large VMs, going up to half a terabyte of memory. We're going to soon announce VMs that are going to go far in excess of that as well. So it'll be very, very large from the perspective in terms of the size of compute we can actually offer. Now, one of the key things that comes up on a regular basis is, how can you ensure that, your cloud and the resources that put in your cloud are in fact secure? And sometimes I get customers ask me saying, well, here are our security standards. Can you go ahead and meet those? And our response is very, very simple. We adhere to international standards. We have a page on our website. If you go to azure.com and look under support or go to the way to the bottom of the page, there's a section called the Trust Center, which basically lists out all the certifications that we have, how we protect your data, how we ensure security, privacy, compliance of all your data that you store in our cloud services. That's there for anybody to be able to take a look at. It's updated regularly based upon in terms of what the new certifications we have. But we have a lot of certifications. One of the important ones, for example, is ISO 27018, which is the cloud privacy certification, which basically states what we do with your data. And we don't do anything with it because it's your data. The other one that's not actually listed here near the bottom is we also adhere to the Canadian privacy certification as well. So, when it comes to Canadian privacy requirements and legal requirements, we do adhere to those as well. And a whole bunch of other types of certifications around the world. So very often when I talk to customers about this and we look at the certifications that we have and what we comply with from a standpoint of all of our data centers around the world, because these apply to all of them. It's not just one, it is in fact to all the data centers and the different workloads that are there. We want to make sure that the customer is in fact feeling pretty secure about storing the data within Azure itself. Customers typically will look at this and compare to their own security standards, and they will look at, which ones do we adhere to versus what they adhere to. And very often you'll find that what we have in Azure in terms of security and privacy and governance and compliance is probably far more than most organizations have in their own on-premise environments as well. In fact, the U.S. government and U.S. Department of Defense, and in fact, the U.S. intelligence organizations are actually leveraging Azure in a big way as well. Because they feel that we have a very, very secure environment, and as you guys can probably imagine, they tend to be very security conscious. The other thing to keep in mind is this is not all Microsoft, right? Azure is very much an open cloud. Yes, we have a lot of Microsoft workloads in Azure. We have a lot of virtual machines in Azure that are running Windows, but ironically enough, our fastest growing workloads are in fact in the open source space as well as in other applications. So we're doing a lot of things around SAP on Azure, so we're certified to run SAP workloads in Azure. Oracle databases, DB2 databases, MySQL databases, as well as a huge collection you can see on this particular slide. These are all certified and have partner solutions that can in fact run on Azure. So if you are an Oracle user and you want to run an Oracle database or an Oracle database-based application in Azure, with the middleware, the front end, and the database in the back end, that is fully supported by Oracle, and to the extent that if you call them for support and you say, well, I'm running an Oracle workload and running it on Azure, they're not going to ask you to run it on-premise in a physical machine like they may with some other environments. So we are, in fact, very open. We have a very large open source presence, and on top of that, we also tend to be very active in the open source community. Some of the largest contributors to open source are, in fact, Microsoft employees. So it's kind of interesting as well. But things like, WordPress, Drupal, Cloud Foundry, for management, things like Chef and Puppet are all available. From a database perspective, Hadoop, ClearDB, Cloudera, MySQL, MongoDB, Couchbase, DB2, and Oracle, like I mentioned before. Full support for Docker containers, Oracle Linux, SUSE Linux, Red Hat Linux, FreeBSD, and so on down the line. It's quite a large collection. They're all available from what we call the Azure Marketplace, where you can simply search for a particular solution and then be able to instantiate that either as a VM or a platform as a service offering within Azure itself. All right, so now that you got a very brief idea in terms of what Azure is, the next logical question very often ends up being, well, okay, great. Now, how do I actually start to move my applications up into Azure? And the reality is there's a couple different ways. You can start fresh, right? You can say, I'm developing a new application, let's say a new website, and what I want to do is I want to now develop that website in Azure as a web app and be able to have that running in Azure from that particular point forward and not really have any of that on-premise at all. You could potentially, link that to on-premise. We have the capability to link Azure networking with your on-premise network through either a secure site-to-site VPN or through an MPLS circuit using what we call our Express Route offering, which gives you high-speed network connectivity at up to 10 gigabits per second and a dedicated connection. All those are available to you. You can kind of start from scratch and build new apps and deploy those. But the reality is, how most customers actually are starting to move to Azure is to take something that they have running on-premise and start to make that available in Azure in one of two ways. So the first one is, a lot of organizations, especially small to mid-sized organizations, have what I would call a DR situation. I call it a DR situation because most small organizations can't afford to have two data centers and be able to do replication of their primary production workloads from one data center to another, because that's just a very, very expensive proposition. So one of the things that's available in Azure that is a service that is very, very commonly used by customers of all sizes, but is probably one of the first workloads to look at, is to be able to create a disaster recovery capability for their on-premise workloads. And one of the tools we have for that is something called Azure Site Recovery. The idea behind Azure Site Recovery is actually very straightforward. We will take your on-premise VMs, whether they're running on VMware or Hyper-V, or whether they're physical servers even, right? And we will replicate those particular VMs into Azure and store them in Azure storage. And then if anything goes wrong with your on-premise environment, you can then turn those VMs on in the cloud and continue to operate in the cloud. And you have the capability to do things such as recovery plans, which will then specify the order in which the VMs come up. So we have application consistent capabilities. They will also specify in terms of things like DNS changes that have to get made, or anything that is required to ensure the application is properly instantiated when it actually gets into the cloud. That DR tool is actually something that is very heavily used, and one of the organizations that I talked to, one of the CIOs, when we had a conversation after they started using this, the statement that he made that I just love is, Azure Site Recovery just works. You turn it on, and it just replicates your stuff. It just works. If anything goes wrong, you simply can instantiate what you have in the cloud. That same tool, though, can also be used to migrate your applications from on-premise to Azure, because essentially you're going to replicate what you've got, your existing production environment, an exact copy thereof, and move it up into Azure. And you can do things such as test migrations, or test failovers, where you're not actually going to impact your production environment in any way, shape, or form. What you're essentially going to do is you're going to instantiate a copy of production in a bubble in Azure, and you can then test whether or not everything is working properly. That test failover is a great scenario, it's a great thing to use for a number of situations. A, to help with the migration process to make sure things are working, but also to assist with things such as patching. Everybody loves patching. Everybody loves patching production. Patching production is always a lot of fun because you're always worried it's going to impact what the user can actually do. Well, if you use Azure Site Recovery to create a DR of your production environment, you can do a test failover, test your patches at an exact copy of production, see if there's any issues, and then when you actually do apply your patches to the production environment, you've already gone through and looked at all the possible situations that could occur, mitigated those, and you can be pretty confident that your production patch is going to work, that you've done it in an exact copy of production. So that is one particular use case around that as well. But again, the other thing that we can do is we can replicate the entire environment into Azure and then migrate it, i.e. you can do what's called a planned failover, where you simply, quiesce your on-premise environment, do a final replication of everything that was there into the cloud, instantiate your cloud environment, and never turn production back on. You simply stop doing replication. Now your cloud-based environment, your Azure environment, is in fact your production environment, and you've taken what you have on-premise, moved it into Azure, and it's the exact same thing, so it's going to work the exact same way. Again, a lot of customers in the process of doing that. I've actually got 3 customers in the West, 2 of them in Alberta, that are in the process of getting rid of their on-premise data centers completely by 2020 and using Azure Site Recovery to start migrating their workloads as well. So that is a very, very cool capability. So again, replication, migration is there. Again, if you're not running the virtual machines in the cloud, only thing you're actually paying for is cloud storage, right? So there's no additional cost. So it actually is a cheaper solution than running a secondary data center, and the only time you actually end up paying for anything is when you bring up those VMs. And by the way, for the disaster recovery scenario, if you do fail over into the cloud because something's gone wrong with your on-premise environment, there is a possibility to also, or capability for you to also fail back so that you can now, run production once again on-premise. So, it's a migration tool. It's also a DR tool. It's a very, very robust set of capabilities that works with, again, VMware, Hyper-V, physical machines as well. And we also will take Amazon VMs that you have in your Amazon environment. We can replicate those to Azure, and you can have now either a disaster recovery scenario for your Amazon workloads on Azure, or you can migrate those workloads from Amazon to Azure using the exact same set of tools. All right? So again, migrate applications from multiple environments, VMware, Hyper-V, physical Azure, and Amazon Web Services. Migration testing, there's no impact. You do test failovers, and until everything's working properly, don't actually do the actual migration. And the application themselves can move over with relatively quick, near zero downtime. In that, the only time it takes is however long it takes to instantiate the VMs in Azure, bring them online, and run the recovery plan, which could be minutes as opposed to hours. I don't know how many of you have actually done disaster recovery testing. I used to do that in my previous life, and it was always the least fun weekend every quarter that we had to do. And the company that I was working for at that particular point in time, in the time I was there, never had 100% successful DR test. Whereas here, without impacting production, you can do a test failover and see exactly what's going to break and what else you may need to go ahead and mitigate. No questions in the IM window, Luke?
Nothing yet. I don't see. I just posted the Azure Trust Center link for everyone's reference.
Okay, cool.
I think we've got one coming in here from Alex, it looks like.
Cool. I will keep on going. I'll answer the question as we go through.
Okay.
How do you execute tests to ensure readiness? It's really a push of a button. Once you configure a replication, there is a option within the Azure portal for that particular workload to say, I want to do a test failover. You click on that, basically specify which network you want to connect it to, and then that process just kicks off automatically. And you can then do a test failover and verify everything's working. So you're going to instantiate your VMs in Azure, and then once they're instantiated, you can then connect to that particular environment and make sure everything is working properly. So, once you've actually moved your workloads into Azure, the next obvious question is, now what? Right? I've got stuff up there. How can I go ahead and monitor this? How can I ensure everything is working properly? And if I have done a migration of my on-premise environment to the Azure environment, how can I ensure that we've got proper DR and so on? And we do have some built-in capabilities within Azure to, help protect data and ensure everything is working properly. So, from a storage account perspective, right? So every piece of data you store in Azure, when you create a storage account, is going to either be locally redundant, which means we're going to make 3 copies. These are 3 synchronous copies of your data in one particular region. And you optionally can also replicate that to a second region using what we call geographically redundant storage. We'll make 3 additional copies in a second region in case something happens to the first one. So with locally redundant storage, if we lose a physical disk, you'll actually never know because we have 3 copies that are being written to simultaneously. It's a synchronous write. If an entire region goes away, we will have the other data, the other copies of your data in a second region available as well, and you can instantiate your VMs from that perspective. So, there's some kind of built-in capability around that, but, customers have actually gone a little bit further. So, one of the tools we have to be able to go ahead and monitor what you have in Azure and as well as monitor what you have on-premise together is this capability called Operational Management Suite. So it gives you a number of different things. Backup and disaster recovery is one. Azure Server Recovery is part of that piece as well. But things like security and protection, Azure Security Center is an element of that. We can monitor how secure your VMs are. Ironically enough, whether these are on-premise VMs or even physical servers or Azure-based VMs, we can monitor things such as the patch levels, whether they're properly patched, whether the firewall's properly turned on. There's a whole number of different things we can help you monitor and ensure your environment is in fact secure. And that gives you good visibility in terms of how things are running. If there's performance things, performance elements and so on, the instant analytics and log analytics piece will actually allow you to go ahead and be able to take a look at what's happening from a performance perspective. Also use that to trigger alerts that can then, potentially change the size of a VM or instantiate additional VMs or additional services. So great tools around that. And that's using some of that configuration automation piece as well. And there's also a tool, Service Map, which allows you to kind of get a sense of, from a dependency perspective, which applications, as you're looking to move them into Azure, have dependencies between them. So, which VMs are talking to other VMs on what particular ports to ensure that you have all that information available. So when you are taking an application workload, let's say an entire SharePoint infrastructure or an entire, ERP system, that you have a sense of all the different VMs that are involved with that, so that when you do, in fact, define DR for them or define a migration plan for them, all the elements are included, so you're not actually missing anything, and it'll all work properly as required. So there's a lot of elements that we have through OMS, through the Operations Management Suite, that help you kind of analyze that, automate some of the key capabilities, protect the workloads, but also secure them, and even be able to understand, who's connecting to the different VMs. Are there any particular issues? Is anybody trying to breach your environments? All those tools are available through the OMS suite as well. The other element to keep in mind is, like I said before, you have, let's say you have your VMs running in one particular region. In this case, we have East US for an example. And you want to make sure that in case anything happens to our East US region, you can continue to work. You can also use Azure Site Recovery to replicate between Azure regions. This is currently what we call preview, which essentially means that you can have Azure Site Recovery do replication between, East US and West US on the Azure side, have your VMs replicated between those two different locations, and then these, second location, the West US, for example, just use storage and don't actually use the compute until you go through and actually turn those VMs on. So the same thing you'd have from on-premise to the cloud for disaster recovery or migration, you now have within Azure between two different Azure regions to ensure that, in case one of our regions goes down for any reason, all your workloads are available in a second region. And I've actually got customers that are doing that right now because of the fact that they're into a situation where everything is in Azure and they want to make sure that worst case scenario they're protected as well. Right? And we also get capabilities with regards to Azure Backup to be able to back up both on-premise workloads as well as Azure-based workloads, VMs, as well as things like SQL Server database and so on through the Azure Backup service. So not only do we do DR, we also do backup, and disaster recovery and backup are two different things, but they are really all about availability of your applications themselves. And then the reality is most customers aren't doing a lock, stock, and barrel migration to Azure. Most customers are actually in a hybrid mode, where some of their workloads are on-premise and some of the workloads are in the cloud. So one of the key elements then is, how do you ensure that you can have those two coexist? And ensuring that they essentially end up becoming part of the exact same infrastructure, or at least appear to be that way, so that there's no real discernible difference between what's running on-premise and what's running in Azure in the cloud. One of the things that we have with regards to that is, if you look at, for example, dev test workloads, we use Azure Site Recovery to replicate your applications. We can then, keep the replica available. We do a test DR, for example, a test failover, and then create a point-in-time copy of that, and then be able to have users access that, dev test copy as a separate environment for doing dev test itself. Now, at the bottom of the screen, there's some things that I do want you to kind of that I want to highlight. Two terms, VPN and ExpressRoute. So one of the ways that you can extend your on-premise infrastructure into Azure is to create a site-to-site VPN between your on-premise network and your Azure virtual network, which essentially is, a IP address space that you created in Azure. When you create a site-to-site VPN, you essentially are making the Azure virtual network appear as if it's part of your on-premise infrastructure. So, virtual machines in Azure communicate back to on-premise, virtual machines on-premise can connect, and users can communicate to VMs and other services sitting in Azure as well. And again, there are rules and tools around that to be able to secure it more fully. So you can limit which VMs can communicate with which other VMs through something called network security groups, which essentially is being able to kind of determine which ports are going to be able to be open for which particular VMs and in what direction. So we have that capability in there as well. You have the capability to use user-defined routing. You can, for example, use third-party firewalls, F5, Palo Alto, a whole slew of others as well, to ensure that you've got that security between on-premise and the cloud in place as well. But really what ends up happening is your Azure network now looks like it's part of your on-premise network and becomes part of, one huge whole, and you are running essentially a hybrid infrastructure. The site-to-site VPN will use the internet, so you are going to be potentially impacted by, a Kardashian video getting released and everybody wanting it at the exact same time because it is traversing the internet. Not that that's going to happen anytime soon, but it's possible. But if you want to have dedicated connectivity between your on-premise infrastructure to our network without actually traversing the internet, we have something called ExpressRoute. An ExpressRoute essentially is an MPLS connection between your network and our network is dedicated. So you would connect your network through a network provider like such as Bell today, TELUS, and Rogers in the future, or an exchange provider such as Equinix or Cologix. And so your MPLS network would connect to them. They would be the, essentially the connection point between your network and our network, and you would then have the capability to go directly from your network into our network to that MPLS connection. And the other element of ExpressRoute that's important to note is that we do have an SLA for that, so we guarantee a certain level of speed and performance. And you can also go up to 10 gigabits. So your network connectivity to our network can be up to 10 gigabits in a single pipe, and that's actually very, very quick, depending upon what your actual requirements happen to be. But the advantage of ExpressRoute is that now you're really are truly making Azure an extension of your on-premise infrastructure. If you go up to 10 gigabits, that gives you very, very quick performance between our two networks. But DevTest is one of those workloads that customers move into Azure very quickly. They replicate their on-premise environment, their production system, move it into Azure using Azure Site Recovery. Once that's done, they'll basically do a test failover, take those VMs, make a copy of them, and that becomes their dev test environment that they can go ahead and do testing on as required. And they can destroy the test failover environment, or if they need that environment for a short amount of time, they can simply do the test failover, do all the development that's required, destroy the environment afterwards, and then be able to go ahead and apply it to the new version. Okay. Another scenario with regards to hybrid cloud has to do with storage. Now, I'm going to ask you to actually do something in the IAM window and just tell me how many of you are using file shares. Just do a IAM or +1 or just something. Let me know how many have file shares because I can't see your hands. You guys have a lot of file shares? Yes? Andrew does. Anybody else? Marcus. So I'm going to ask you another question. For those of you that have answered, even the other ones as well, how often do you guys clean up those file shares in terms of delete old files? Waiting for the answer that I'm looking for. Somebody's going to say, not often, never. Yeah, there you go. That's about right.
Oh, right? Never. I was waiting for never.
Yeah, we got never.
Yep.
So the interesting thing is everybody is in the exact same boat, right? You have all these file shares. They're taking up expensive storage on premise. You really can't get rid of them. You really can't clean them up, and you probably have multiple copies of the exact same file. So we do have an appliance that basically customers are starting to use in a big, big way called StorSimple, which essentially is either an on-premise physical device or an on-premise virtual device that essentially will allow you to do automatic tiering of workloads like file shares, videos, image files, whatever is going to be kept for a very long period of time to Azure. Now, the advantage of doing that is you're now going to have the most frequently accessed data, i.e. the stuff people are using today, available on the device on premise. But anything that has been touched, typically within a month or 2 months, whatever period, hasn't been touched, is now going to be tiered automatically into Azure, but still available. So what's going to happen is that file share is going to have all your files listed, but the only ones that are going to be physically on premise are the ones that are most frequently accessed. But anything else that has been there, maybe someone wants to get a file from 2 years ago, once they click on it, will automatically get downloaded from Azure to the device, and they can then go ahead and get access to it. So instead of having, 1 second access to a file, it might take them 5 or 10 seconds to get that file to come down from Azure, but it's totally transparent to the user. What this is actually really, really good for from a hybrid perspective is, A, it reduces your on-premise storage requirements for things like file shares, video files, image files, and so on. And I'm actually working with a number of police departments that are looking to do this for their cameras that they have on the officers right now. So, the body cams. So, they need to keep that footage for quite a long time. So, instead of having that footage in big SANs on their on-premise environment, you're actually starting to leverage StorSimple in order to be able to go ahead and have that automatically uploaded into Azure using cheaper Azure storage. Before we actually upload those files into Azure, we dedupe the data, compress it, encrypt it, and then store it encrypted in Azure. And the encryption key remains on-premise with the organization that actually owns the device, right? So the key thing there is, everything is stored in the cloud, but it's in an encrypted form, it's secure, and then the organization that controls the encryption key. Piece of advice, don't ever lose the encryption key, because we can't get your data back if you do. But this is actually a very, very cool type of hybrid cloud type scenario, because most organizations face this problem. Most organizations can't afford to actually, continue to expand their storage footprint, because that gets very expensive. But this gives them a low-cost solution to be able to go ahead and start to leverage Azure for hybrid storage, keep a device on-premise, but still have all the data available as required. And we can also do things like cloud snapshots of whatever's on that device, so it can serve as a backup as well. You can, for certain high-performance workloads like VMs, even pin certain types of LUNs, so they're local device only. They actually don't ever end up tearing to the cloud, but you can still do snapshots of what's there to the cloud as well, so your backups become automated and so on down the line. So a great way to kind of, have that hybrid NAS or SAN storage capability, local or tiered volumes, gives you the automatic offset data protection using snapshots, and data mobility for enterprises as well. I've actually had a customer use this when they were moving data centers. So they basically, had the device on-premise, and they wanted to move data centers, but they had to have both at the same time. So they installed a second device in a different data center, just simply replicate data to it, and it was able to be used from that perspective as well. So another possible option. Then the other key thing to keep in mind is when you're actually looking at the cloud, don't think servers, right? Think services. Typically on-premise, when we're actually looking to migrate workloads to the cloud, we're looking to run workloads on-premise, it's, we need to get this server is going to run this number of VMs, got to make sure it's the biggest server that we can actually get for that amount of money, and we're going to run servers. In the cloud, we think in terms of applications and services. Now, what is the totality of the requirements of an application in order to run successfully? And then we actually move that to the cloud. We're looking at that application, that service as a whole, that ERP service providing to customers, or that CRM service. What's actually required in order to be able to go ahead and do that? So, the cloud model is more loosely coupled apps and microservices. We use industry standard hardware, and a lot of the processes and configurations are in fact standardized. There are VM sizes that you can choose from, but you can't say, well, I want a VM that's got 200 gigabytes of memory and 64 CPUs. Well, if that's not one of the standardized options, you're not going to be able to get that. So there is heavy-duty standardization. So it's a different model, and typically it can actually be a cheaper model for a lot of organizations if we implement it properly. I mean, there's no reason to run dev test environment 724. On-premise we do because we've already invested in the hardware. In the cloud, it makes no sense, to do that, because as soon as you run things, you're going to actually pay for compute, which is one of the more expensive elements. So it does require a mindset and a bit of a shift in terms of how you do things. And again, the standardization is opposed to highly customizable elements. The other thing that's important to note is, getting from Azure to Azure from on-premise, in some cases you may want to run similar things that you're running in Azure on-premise as well. So we have the capability in Azure, for example, to have that cloud infrastructure, have infrastructure and platform services available. Use tools like Azure Resource Manager to manage that entire environment, organize things. And I'm using the PowerShell portal or the DevOps tools to create those, to instantiate those objects in Azure or the services. We're releasing very soon something similar on-premise, something called Microsoft Azure Stack. We have customers that are saying, well, that's great, I'm going to run workloads in Azure, but I also want to have certain workloads that are, for compliance reasons or for whatever reason, I can't actually run the public cloud because I'm not allowed to. So, but I want to have the same kind of capabilities and the same types of service-based model available on-premise that I can go ahead and have my developers use so that when we develop an application, it's going to use the exact same service. And if I do want to deploy that application later on in Azure, or I want to do dev for that application in Azure, but I want to deploy it on premise, I want to use the exact same types of tools. So what Azure Stack is essentially is all the Azure capabilities that are available in terms of the resource manager model and everything else that you can now run on premise on pre-certified hardware. And this is really something that we're targeting at organizations that do have those strict compliance requirements. We have, for example, government organizations that are looking to do this. I have a nuclear regulatory organization or nuclear power generation organization that's looking to do this, mainly because by law they can't store some of their data in the cloud. It's just not something that's currently available to them. So the idea behind Azure Stack is to give you that same capability on-premise that you would have in Azure, and then you define in terms of what that happens to be. And it's one Azure ecosystem for developers. It's a unified application platform, and you can move whatever you're running in the cloud in Azure to Azure Stack and vice versa by simply redeploying it, using the resource manager model, using templates and so on in that new environment. So it makes it a lot easier to kind of have that, similarity between on-premise and the cloud as well. And Azure Stack should be available probably by the third quarter of this year from hardware vendors. And it's priced in a similar fashion as well, in that you're actually kind of paying on a service model as opposed to paying for the hardware itself. So it comes down to it's one Azure ecosystem with 32 regions operational, actually 35 right now, 38 announced. 100 service providers around the world that actually can, in fact, help you with regards to getting your applications up in Azure as well. And we've got thousands of enterprises, large and small, public sector, private sector, highly regulated, all different types of environments available that are using this particular capability today. And with that, we've got, about 10, 15 minutes for questions?
We have about 9 minutes for questions.